Hello everyone. So today we'll be discussing the chapter about the particulate nature of matter. And during this chapter, we will be looking at 4 points. The first one is the distinguishing properties of solids, liquids, and gases. The second one is doing a description of the structure of solids, liquids, and gases in terms of particle separation, arrangement, and type of motion. Then in the third point, we will be looking at a description of the changes of state in terms of melting, boiling, evaporation, freezing, condensation, and sublimation. Then the fourth and the last one will be explaining the different changes of the state in terms of the kinetic theory. So here, as you can see that there are many different kinds of matter. You know all that you can distinguish different kinds of matter, and these are all actually the substances and materials of which the universe is composed. Okay, so all the different substances and materials of which the universe is composed are called matter, and we can distinguish or differentiate between two properties which are in common for those materials or those substances. The first one is that they can occupy space, which means that they have volume, okay? And the second one is that they have a mass, they can have a mass. So we can give a definition for matter as anything that has a mass and that takes up space, okay? So anything you can see and you can touch, which means anything which has a mass and take up space, we can call it matter. So, and we can distinguish three physical states of matter. There are three physical states of matter, which are the solid, the liquid, and the gas. And actually, these three physical states, what we call physical states, depend on temperature and also on pressure, which means that by changing temperature or the pressure, we can change the physical state of matter from solid to liquid or from solid to gas or from liquid to gas. Okay. So as you can see here that the three states of matter can be represented by simple model, which means that we will be giving a simple model to matter, to represent matter, which is represented by different small solid spheres, okay? The particles actually which are making the matter are represented with different or small spherical spheres. And as you can see here in solids, which is the image here we have in the left, solids, we can see that those solid spheres are in regular arrangement and they are close together, okay? They are close together in a regular arrangement. In liquids, the particles are in random arrangement and they are close together. Okay, then in gases, as you can see here, that the particles or the solid small spheres are randomly arranged and they are spread apart. Now here we can see the general characteristics of the three different physical states. Okay, so this table is gathering these different general characteristics. So for solids, they have a fixed volume. Okay, solids have fixed volume. Their density is high because, as we said before, that the particles are stuck together to each other, one to the other. Okay, so they has a fixed volume, high density. The shape is definite shape. They have a definite shape. Then their fluidity, they does not flow. Okay, now for the physical state liquid or for liquids, liquids has a fixed volume. Okay, they has a fixed volume. The density is moderate to high, and the shape, they have no definite shape, which means that they can take the shape of the container. For example, if we put water in a glass, it will take the shape of the glass, and if we put it in a bottle, it will take the shape of the bottle. They don't have no definite shape, and they are fluid, which means that they generally flows easily. And now, for the third physical state, which is the gas, gases has no fixed volume. They expand to fill the container. Okay, their density is low, then the shape, they have no definite shape, which means that they take the shape of the container, like the liquids. And in terms of fluidity, they flows easily. Now let's see this point, which is let's give a description of the structure of solids, liquids, and gases, which means the physical states in terms of particle separation and arrangement and the types of motion. Okay, so let's see for the solids. As you can see in this image here, representing the different particles which are packed together, we can say that in solids, the particle have the least energy. Okay, we can say that in solids, the particles have the least energy, which means that they are just vibrating. The particles here are just vibrating and they are not moving. Okay, they are not moving. In liquids, we can see that the particles have more energy than those in solid. Okay, in the solid. Now, in liquid, the particles start moving. They start moving, but they have less energy than those in gases. They start moving slowly. Okay, this means that this movement can allow the solid to become liquid, to change state. Than in gases, the particles have the most energy as they are the most spread apart, as you can see here. The particles are spread apart one from the other. So the motion is more random and frequent. They are moving randomly in the gas. Now let's see the description of changes of state in terms of melting, boiling, evaporation, freezing, condensation, and sublimation. So let's start with freezing and melting. So for the melting is the physical change from solid to liquid. So now we want to pass from solid to liquid. This requires heat energy. For example, if we want to melt a piece of glass into water, we need to heat it. Okay, so this requires heat energy, which transforms into kinetic energy, and this allows the particles to move. I said before that the particles, if the particles are starting moving, we can change the state from solid into liquid. So this can be happening by bringing heat, okay? And the reverse transformation is called freezing, which means passing from the liquid into the gas. This requires a significant decrease in temperature. A decrease in temperature means removing energy from the particles in a way to allow them to be stable, to be more stable or have less energy. And this can be happening, as we said here, by a significant decrease in temperature or what we call a loss of thermal energy. Okay, now let's see the two transformations, which are condensation and evaporation. Okay, then the evaporation. Talking about the condensation is the physical change from gas into liquid, and this can be happening by loss of energy. The particles in a gas are moving randomly and they have high energy. So during the condensation, these particles they will lose energy. Then this lack of energy to bounce away will allow them to approach each other and change state from gas into liquid. And actually, this process does not need no energy. Okay, And let's see now the third one, which is the physical change from solid into gas directly, okay, is called sublimation. Sublimation, okay, and the reverse process is called deposition. The sublimation happens to only few solids, and we can give here the example of the iodine and the dry ice or the carbon dioxide, which is, for example, found in the extinguishers. The reverse reaction of sublimation also happen, and it's also called sublimation, but sometimes we can call it deposition or sublimation. Now let's see uh, the state of matter based on the kinetic theory. Okay, actually, the kinetic theory of matter describes the states of matter, which are the three states we talked about, and the changes or the changes between them in terms of movement of particles. Okay, so in solids, as we said before, that the particles are packed very closely together. Okay, this is due to what? Due to the force, to the strong attraction forces between those particles. So in solids, we have strong attraction forces between the particles. This is what allows them to be packed together closely and give the physical state, which is solid. In this physical state, as we said before, the particles only vibrate in position, but they cannot change their position, which means that they cannot move. They are only vibrating. In the liquids, actually, the liquids are, or the particles in the liquids are in an irregular and fixed pattern. And this is due to what? To the weaker attractive forces in liquid. By actually heating or by bringing heat, we allow to break those attraction forces between the particles, which allow the physical change from solid into liquid. Okay, so this is why in liquids the particles are in an irregular and fixed pattern due to the weak attractive forces. Okay, so the particles now are free to move and slide past each other. So in liquids the particles can move and slide past each other. So this is why in liquids, or we can say that liquids can adopt the shape of the container and they can flow. Okay, so in the gases now, there are a random movement in particles. So the particles, we said, as we said before, that in gases, the particles are moving randomly. And this is due to the lack or to the absence of the intermolecular forces. Okay, so in gases, there are no intermolecular forces. So this is why the particles are moving randomly in no defined pattern, okay, which means randomly. So we can add here that the particles are far apart and they move quickly. They move by 500 meters per second, okay, which is a high speed. So in all directions, so they collide with each other and with the sides of the container. Generally, we can say here also that the gases have no fixed volume since there is a lot of space between the particles. Okay, so this is all for these four first points. Thank you for watching and bye for now. See you